Over the past 50 years, the number of natural disasters in the world has increased fivefold, and you can bet that somewhere in the world yet another natural catastrophe is happening right now. Over the past half-century, these disasters have claimed the lives of more than 2 million people. Ordinary and seemingly harmless droughts have caused the deaths of around 650,000 people, storms have killed more than 500,000, and floods and extreme temperatures have claimed nearly 115,000 lives. I'll tell you more. In this century, the world's largest ocean current, the Gulf Stream, along with the planet's core, could come to a screeching halt. These events don't seem to be mere coincidence. Earth has already been through 5 major mass extinctions, and there's reason to believe that today we humans stand on the brink of the next one. Who knows, perhaps it's already underway. The biggest extinctions in Earth's history are called mass extinctions, and while they didn't wipe out 100% of life on the planet, some species always survived, evolved, and then conquered the world. So, there's a certain point the human population may drop to after a mass extinction without going totally extinct. To find that magic number, we need to take a trip back in time. Around 74,000 years ago, on the territory of modern-day Indonesia, a supervolcano called Toba erupted. As a result, a volcanic winter sped up the onset of an ice age, causing the death of many animals and plants. But what's even scarier is that it affected humans too. During that period, the population of Homo sapiens may have dropped to as low as 3,000 individuals. This process is called a population bottleneck. After a sharp population decline, the narrowest part of the population graph is followed by either recovery or extinction. But since you're watching this video right now, you probably get that humanity didn't die out back then. So, if at least 3,000 people stay on the planet during the next extinction event, our species will survive. But what exactly is threatening us? The first thing that comes to mind after hearing mass extinction is the impact of a giant meteor, like Chicxulub, which wiped out the dinosaurs. It triggered the Cretaceous-Paleogene extinction 66 million years ago. At that time, about 75% of plant and animal species on Earth disappeared. The asteroid was colossal, almost 10 kilometers in diameter, which is 3 kilometers more than the highest summit on Earth, Mount Everest. Moreover, this meteor was hurling through space at about 20 kilometers per second. When Chicxulub collided with Earth, approximately 72 teratons of energy were released in TNT equivalent. This explosion was nearly 5 billion times more powerful than the bomb dropped on Hiroshima. But the devastation didn't stop with the asteroid impact itself. The dust and debris kicked up into the atmosphere literally blocked the sunlight from reaching Earth. As a result, photosynthesis in plants and algae stopped, and they began to die. Consequently, the majority of the planet's animals were left without food. During the Cretaceous-Paleogene extinction, all non-avian dinosaurs and most animals weighing over 25 kilograms ceased to exist. Along with them, ammonites, many other mollusks, plesiosaurs, mosasaurs, and all herbivorous or carnivorous mammals went extinct. However, small mammals that fed on insects or carrion managed to survive. But what about humans? Will we live to see another day if Chicxulub's twin pays a visit? Imagine looking out of your office window and seeing a massive stone larger than Everest, engulfed in flames and coming at you from the sky. What do I do? How do I save myself? These might be your last thoughts before vaporization. Due to the incredibly high temperatures, all living organisms within a radius of 1,000 kilometers will literally turn to ash even before the asteroid hits the surface. For instance, if another Chicxulub were heading straight for Manhattan, it would kill around 105 million people before the actual collision. If it were plummeting toward London, roughly 193 million people would be vaporized in an instant. But let's assume the asteroid struck the same location as it did 66 million years ago. In the first few seconds, nearly 83 million people would die from the heat radiation alone. Meanwhile, wildfires would start raging and forests thousands of kilometers around would be engulfed, eventually consuming all of North and South America. The crater's diameter at the impact site would reach 300 kilometers, nearly the size of 3 English channels. At the moment of impact, so much energy would be released that approximately 70,000 cubic meters of rock would simply vaporize. To put it into perspective, that's 17 times more than the volume of the Grand Canyon. Just 8 minutes later, all that rock would begin to condense again, transforming into scorching ash. Furthermore, the new Chicxulub would trigger an earthquake with a 10.1 magnitude on the Richter scale. Its tremors would likely be felt from Colombia to Kansas. On top of that, the impact would unleash a sudden wind gust traveling at thousands of kilometers per hour. It would flip cars and destroy buildings within a radius of 2,200 kilometers. Along with the devastating earthquake, this would take the lives of nearly 350 million people. But wait, there's more. If an earthquake is inevitable, so is a tsunami. In this case, the wave would reach a catastrophic height of 1,500 meters. The tsunami would hit the coastlines of Europe, North Africa, and Greenland, and even reach as far as New Zealand and Australia. It would be about 30,000 times more powerful than the deadly tsunami in the Indian Ocean, which back in 2004 claimed the lives of around 230,000 people. If the Chicxulub scenario played out today, the victims of this colossal wave would number at least 340 million. But the worst is yet to come. The massive amount of ash will rise into the skies after the impact and plunge the world into darkness for 3 years. You might think darkness can't kill you, but it'll destroy most of the plants on the planet, along with all domesticated animals. The endless night will gradually deplete all sources of food and lead to the death of 70% of all living creatures on Earth, including humans. The darkness will entail a sharp drop in temperature, which will also take many lives. Due to this drastic, catastrophic reduction in the human population and the chaos left by the new Chicxulub, medicine won't be able to effectively restrain the progress of diseases. People with chronic illnesses will be most at risk. According to statistics from the Centers for Disease Control and Prevention, that's over half the population of the United States. As a result, the impact of this gigantic asteroid will reduce the human population on Earth by more than 90%. And that's a fairly optimistic forecast. The good news is that humanity will indeed survive this mass extinction. The bad news is that such an apocalyptic scenario is entirely possible in 2029, as Apophis will pass dangerously close to our planet. Fortunately, scientists' suspicions. It has not been confirmed that we might collide with a meteor, but if such a meteor were to hit Earth, the force of the impact would be about 500 megatons, which is 10 times worse than the testing of a super-powerful nuclear weapon. However, asteroids aren't the only threat of mass extinction from space. Let's travel back 445 million years. Earth looked quite different then. The supercontinent Gondwana was a vast desert at a time when the first land plants were just emerging. Life in the oceans was evolving rapidly. It was during the Ordovician period that the so-called Great Ordovician biodiversification event took place, when the number and diversity of marine species increased manyfold. And who knows, perhaps life would have continued to thrive underwater to this day if it weren't for, well, in truth, scientists are still uncertain about what caused the Ordovician Silurian extinction, one of the most massive extinctions in history. During that time, 85% of marine species vanished from the face of the planet, nearly half of all animal families. The loss in diversity was immense. Scientists have several hypotheses about what could have caused this disaster. One of them is a supernova explosion. But how could a star from the depths of space wipe out 5/6 of all life forms on Earth? And could a supernova cause the extinction of humanity? In 2016, a researcher from the University of Kansas, Adrian Mellett, published an article in the science journal *Nature* that provides evidence of the direct influence of supernovas on Earth's organisms. Mellett examined samples of ocean floor collected from different parts of the world, and in each of them, he found an isotope of iron called iron-60. This radioactive element has a half-life of 2.6 million years, and since our planet is over 4.5 billion years old, this iron isotope should have decayed a long time ago. So where did it come from? The thing is, iron-60 is formed during explosions of supernovas. Therefore, Mellett and other scientists believe that approximately 2.5 million years ago, a supernova appeared at a distance ranging from 150 to 300 light-years from Earth. This is why there are still remnants of radioactive iron on Earth. Now imagine that this kind of star exploded much closer, let's say just 30 light-years away from us. At such a distance, the first thing we would notice, apart from a beautiful view in the sky, is a bright blue light. It wouldn't disappear during the day or night for a month and would disrupt the production of melatonin. This hormone is responsible for the sleep process in humans. Although insomnia wouldn't be our biggest problem. Along with the light, Earth would be bombarded with a surge of gamma radiation. These cosmic rays ionize the air as they knock electrons out of atoms, creating a difference in charge and forming lightning. This will trigger large-scale forest fires all over the planet. The hardest-hit regions would be North America, parts of South America, Europe, North Africa, and Asia. Besides the immediate damage from the fire, humanity would face long-term consequences. Due to the burning, a substantial amount of carbon dioxide would enter the atmosphere. For instance, during the 2016 fires that engulfed 2/10 of the Amazon rainforest, approximately 30 million tons of CO2 were released. That's roughly the same amount Denmark emits into the atmosphere in an entire year. Now imagine how much carbon dioxide would be released if all the forests were on fire. We'd have a good chance of suffering the fate of Venus, becoming the most hellish planet in the solar system. Before that, humanity will have to survive the gamma radiation, which would cause catastrophic lightning strikes worldwide. Following the supernova flash, a stream of muons, unstable elementary particles, would reach Earth. Their impact on the human body can be compared to several consecutive computer tomographies. In addition, X-ray radiation that hits Earth after the gamma-ray burst may destroy the ozone layer, leaving humanity without protection from ultraviolet light. This wouldn't result in just some regular old sunburns. DNA mutations and cancer would claim millions of lives. Our future would resemble the fate of marine life during the Ordovician period. Still, humankind would probably survive this event, although our population may decrease by about 90%. Scientists continue to debate how close a supernova needs to be to Earth to cause a mass extinction. Some say 30 light-years, others say 300. Currently, the nearest star that could turn into a supernova is not Betelgeuse, but Ik Pegasi b, located just 154 light-years from our solar system. This event might occur in roughly 2 billion years, which is relatively soon on the cosmic time scale. Yet before we face threats from space, the people of Earth could be destroyed by Earth itself. Around 200 million years ago, our planet suffered the largest biodiversity loss of the Mesozoic era, the Triassic-Jurassic extinction event. At that time, almost all reptiles disappeared except for the ancestors of dinosaurs, as well as amphibians and the entire class of conodonts, creatures similar to eels. Overall, about 75% of animal species died out. The cause of this catastrophe wasn't a meteorite or a supernova explosion, but more precisely, volcanic eruptions that altered its composition. During the Triassic period, in the heart of Pangaea, there existed the so-called Central Atlantic Magmatic Province, an area spanning 11 million square kilometers through which anywhere from 2 to 6 million cubic kilometers of magma could have flowed. Scientists believe that a significant amount of carbon dioxide, sulfur dioxide, and toxic mercury were released into the air due to volcanic processes in this area. The concentration of carbon dioxide increased from 1,000 parts per million to 4,000. For comparison, in 2022, the atmospheric carbon dioxide level reached a modern-day record of 421 parts per million. The largest and fastest CO2 release in Earth's history during the Triassic-Jurassic extinction had dreadful consequences. The global temperature on the planet rose by 4 degrees Celsius, and in some places by as much as 10 degrees Celsius. First of all, it affected plants. Estimates suggest that during the Triassic-Jurassic extinction, between 17% to 73% of plant species ceased to exist. With the decline in plant life, herbivorous animals began to die off, followed by predators. At the same time, another apocalypse was unfolding in the ocean. Due to underwater volcanism, water became oversaturated with hydrogen sulfide, altering the ocean's acidity. Along with rising temperatures, this led to the destruction of coral reefs. Oxygen depletion affected all other underwater species as well. But would such an extinction scenario be equally devastating for humans? According to biologists, around 800 million people worldwide depend on the oceans. If most aquatic animals go extinct, these people will simply starve to death. The heat won't be any kinder. The temperature spike in equatorial countries will kill at least 20 million people. But that's just the beginning. Today, someone dies of hunger every 4 seconds, approximately 9 million deaths every year. Imagine how that number would skyrocket when 3/4 of the harvest is lost due to carbon dioxide emissions. Furthermore, the toxic mix of gases and mercury vapors emitted into the atmosphere during the eruption would harm the residents of the former Central Atlantic Magmatic Province. Its remnants are now scattered across various continents, including central Brazil, South America, parts of North and Central America, several European states, and some countries in West Africa. Fortunately, a global volcanic disaster isn't an immediate threat to humanity. But don't. The celebration shouldn't begin just yet, as it's not the only source of CO2 that could doom us. Geophysicist Daniel Rotman believes that by the year 2100, the amount of carbon dioxide in the oceans will increase by at least 300 gigatons, reaching a catastrophic threshold. Rotman's research indicates that this amount would be enough to trigger a new mass extinction event, although it would unfold over about 10,000 years. However, there is something that could wipe out humanity much faster, and it seems this extinction process was set in motion back in 2006. The largest mass extinction of all time, known as the Permian-Triassic extinction, occurred approximately 250 million years ago, during which 96% of animal species disappeared. Ocean inhabitants, vertebrates, and even insects were hit the hardest. During this period, the largest insects ever to exist vanished, along with trilobites and sea scorpions. Experts have several theories about what could have caused such a wide range of living organisms to die out, with the Clathric gun hypothesis being the most terrifying. At the bottom of the oceans and seas, there may exist methane hydrates, watery ice containing a large amount of methane. Like oxygen, this gas can dissolve in water, and the methane remains in a solid or liquid state under the right balance of pressure and temperature. As you might expect, this balance can be easily disturbed. Chemical engineer Gregory Riskin calculated that, at the end of the Permian period, the oceans could have contained around 10,000 gigatons of methane. To trigger a catastrophe, all it would take is a single push. At the beginning of the Permian extinction, there were enough of these pushes, such as the activation of the Siberian Traps, a vast region of magmatic rocks covering an area of 7 million square kilometers. Tremendous volumes of lava erupted from cracks in the Earth's surface, raising ocean temperatures and melting methane hydrates, which released dissolved gas into the water. This change in water pressure could have triggered even more methane release, creating an unstoppable chain reaction. Riskin claims that methane, mixed with air, could create an explosive mixture, and these deadly clouds would have been blown deep into the continent by the wind. A single lightning strike could have been enough to detonate this unique aerial bomb. The scientist believes that these explosions were not only dangerous on their own but also sparked widespread forest fires. Meanwhile, paleontologist Gregory Retalak offers a different perspective on the Permian-Triassic extinction. He doubts it was as spectacular as some suggest, arguing that most creatures may have died from altitude sickness. After methane was released into the atmosphere, the air thinned out, similar to what one would experience at an altitude of 4 kilometers. Animals didn't die from suffocation, but the low oxygen levels could have caused lung and brain swelling. According to Retalak, the survivors of this brutal extinction event were those with thicker ribs and barrel-shaped chests, which allowed them to breathe more efficiently and adapt to the new atmospheric conditions. For humans, such a change in oxygen concentration could also be fatal. However, it seems we don't have much choice. We need to prepare for a potential methane apocalypse. As you might know, methane is a natural gas produced by both human activities and natural sources, such as tropical swamps. Its quantity can increase, but only up to a certain point, where gas absorption and release balance each other out. However, researcher Ewan Nisbet noticed that in 2006, methane concentration suddenly began to grow. By 2020, the rate of methane emissions into the atmosphere had accelerated, breaking a terrifying record. The worst part is that scientists still aren't sure why this is happening. One theory is the expansion of swamp areas, though it's hard to imagine that swamps could have expanded so rapidly. Methane hydrate deposits exist throughout the oceans, and it's possible that an earthquake or an abnormally warm current could disturb them, triggering a chain reaction at any moment. If all this methane were to suddenly escape, the first to suffer would be coastal residents. Around 2.5 billion people living near the disaster zones would die immediately. Then, the explosive methane mixture would travel deep into the continents, igniting massive forest fires with predictable consequences. Simultaneously, the thin air would cause painful deaths from lung or brain swelling. People living at altitudes of at least 2,500 meters would have a better chance of survival, but that's just a little over 1% of the population. Even in the worst-case scenario, there may still be a possibility that humans will endure. After all, 275 million survivors would be 9,000 times more people than those who survived after the eruption of Mount Toba. Yet, even if some survive, the conditions they would face would be incredibly challenging. They would have to learn to hunt for food, protect themselves from the aftermath of the catastrophe, and survive in a world without medicine, transportation, the internet, or communication. Most importantly, they would need to be wary of their fellow humans. One of the most recent extinctions, the Quaternary extinction, which marked the disappearance of mammoths and giant sloths, was entirely the fault of humans.